Question 6G. Just get right into it. Julia is 4 years older than twice Kelly's age, comma, X. So they're kind of telling you in English here, Kelly's age is represented with X. Cool. The product of their ages is 96. Write an equation that models this situation. So we're going to start by writing two expressions, and then we're going to combine them to get that equation that we need. So we got two people here. We got Julia. So in your workspace, don't take up too much space, but you don't need a whole lot of space anyway. We got Julia and we got Kelly. Hooray for both of them. What we're going to do is we're going to represent each of their ages with an expression, and then we're going to put those two expressions together to make that equation with the product in 96 and all that fun stuff. So Julia is 4 years older than twice Kelly's age, X. So we're going to grab Kelly's age because her age is the easiest one to define because they told us her age is X. Lovely. Now Julia is 4 years older than twice Kelly's age. So we need to do 4 years older than twice the X. Okay. So we'll go backwards. So twice Kelly's age. How do I say twice Kelly's age in math symbols? Twice means I'm doing what? So if you hit 10 home runs and I hit twice as many home runs, how many home runs did I hit? You hit 10, I hit twice as many. I hit 20 home runs. What did you do with the 10 to get to 20? You times it by 2. So twicing something means times it by 2. So twice Kelly's age is going to be 2x. 4 years older than, more than, be plus. So 2x plus 4 is Julia's age. Okay? Now, that's not what the question said. It didn't just say represent each of their ages. It said write an equation that models the situation. There's a second part. The product of their ages is 96. So we're going to do that last part over here. Product. Product means which of the four operations in math? Adding, subtracting, multiplying, or dividing. Which one's product? Timesing. So we need to times both of their ages. Oh, I know it's fighting me. There we go. First age times second age equals 96, okay? And then really quickly, we're just going to dump each age into each parenthesis. So Kelly's age is X. Julia's age is 2x plus 4. And this is done. 2 points in the bag. So the big part was we had to product them. We had to times them. If they said the sum of their ages was, you would do the same thing but put a plus sign here. That's it. And then it says determine Kelly's age algebraically, which basically means take that math thing you just made, bring it down here, and just do math to it. Okay. So I'm going to rewrite it down here. I'm going to clean it up a little bit because there's a couple things I need to be aware of to make it nicer. Oh, too big. So I'm going to copy and paste it down here. I'm going to lose the parentheses around the x because they're redundant. They don't help anything. X. I don't mind the times. I do need parentheses around 2x plus 4 because there is a binomial in there. And that whole binomial represents her age, not just part of it. Okay, I'm going to scroll down because we don't need anything else up there. We just need this part. It's the do math part. Now, to do math to this, I look for parentheses. I ask myself, is there distributing? That's always a good first question. And the answer here is yes. Also, we could draw a line if we want. Now, if you have their ages flipped, like if you have 2x plus 4 times x, you can really quickly reorder them to look like this so the distributing is obvious because of the commutative property. A times B is the same as B times A. You can flip it. So I would recommend you put your x in the front, x times 2x plus 4, not 2x plus 4 times x. Okay, so now we quickly multiply. X times 2x is going to spit out 2x squared. X times 4 is positive 4x equals 96. Okay. This is where it kind of depends on how you want to solve it. I'll show you the recommended way that I think most people would think about this. Now, I have an equation. I should be suspicious that I can no longer just draw the line and then just go left and right and solve it the old-fashioned way. Here's why I'm suspicious that won't work. Look at the exponents, look at the variables. I have variables, fine, I've got x's. They have different powers of them. I've got x squared, I've got x to the invisible 1. That means these are not going to be combinable. That means I can't go left and right and do the regular solving like we usually do here. That means I need special techniques. Now this equation has an exponent of 2. This screams to me that it is a quadratic equation, and that means I can use the quadratic formula to solve it. Okay? That's why the quadratic formula exists, because we can't just go left and right and solve this the normal way, because it's a quadratic. It has different powers of x. So to use the quadratic equation, you need all 3 pieces on the same side of the equal sign. 2x squared is good, 4x is good, 96 is in the wrong yard. So I got to get 96 over to his friends. It's a real quick fix. So the opposite of positive 96 is negative 96. So I really quickly, and you could honestly probably do this part in your head at this point. Those cancel, equals, there's nothing left over here. I need something to represent nothing, and in math there's a number for that. It's called 0. Now I've got 2x squared plus 4x. I don't know if I'm going to fit this 96 in. I tried to move them over. Oh, it won't let me. Whatever. I'm being picky. Minus 96, which if you can, it should go in that nook, but I can't fit it. Minus 96 equals 0. So let's get that quadratic formula ready. I'm going to need a lot of space, so I'll probably start to use the space over here and kind of move around in like a letter U shape. Quadratic formula takes us some space, so we got to make sure that we use it. Quadratic formula, I'm toggling to my reference sheet. It's right here, x equals negative b. I'm going to copy and paste it over here. So x equals, ooh, I don't think it's going to fit there actually. I can usually tell. I probably need this little space right here. X equals negative b plus minus square root b squared minus 4 ac all over 2a. Got the formula. Remember, the formula is filled with a's and b's and c's. So let's grab those quickly. A equals, b equals, and I'll put c equals below. So the a, b, and c are getting pulled out of this green guy right here. The a is attached to x squared, b is attached to x, and c is your constant, not attached to any variables. So I'm using this as a reference point. So a equals, a is attached to x squared, so a is 2. B is attached to x, so it's just 4. And c is the constant, and it's negative 96. So those plus and minus signs also impact the number. Next step, we're going to fill in the formula. Everywhere I have an a, b, or c, I'm going to leave open parentheses like a shell. So x equals negative parenthesis plus my square root parentheses squared minus 4 couple of parentheses all over 2 parentheses. Literally it's the same thing. I swapped out a, b, and c with parentheses. All right, let's assemble it. First parenthesis is negative b. B is 4. Another b in the formula goes here. Another 4. I'm just literally using the formula. A is 2. C is negative 96 over 2a, which is also 2. Now for the quadratic formula, I'm going to scoot down a little bit because I don't need all that space up there. Quadratic formula, got to clean up the 3 neighborhoods, clean up top left, basement, and clean up inside the house. House is going to stay with us. Let's go to blue. So I end up with x equals normal fraction bar plus minus the house. Okay, let's clean up the 3 neighborhoods. Outside, negative parenthesis 4. Nothing happens exciting there, so that just comes out as negative 4. In the basement, 2 times 2. We know what 2 times 2 is. Regular 4. Square root. So in the square root sign is still there. So you go to your calculator, you type in everything inside the house. So I'm going to type in parenthesis 4, parenthesis squared, without the square root sign. Parenthesis 4, parenthesis squared, minus 4, parentheses, a lot to type in, huh? And then 2, parenthesis negative 96, and then I click enter, and what do we get? 784, trust. So inside here, it's going to become 784. Okay? Now, when you're doing the quadratic formula, you've got 2 branches now, right? I'm going to go this way and I'll go this way. One branch is the plus version of that blob, and the other branch is the minus version of that blob. So I'm going to write, I've used almost all the colors, haven't I? I'll use dark blue again. I'll use red. It's fine. So x equals negative 4 plus square root 784. Hopefully your paper is a little bit longer than my smartboard file. All over 4. I like to write them both in one go, get them both done, and then x equals negative 4 minus square root of 784 all over 4. Okay, and then it's a calculator thing. Do the plus 1 first. I'm going to move me over here. Oh, no, now I'm going to move me down here. So it's a big fraction, so you got to use the fraction buttons. Alpha y equals enter. So the plus version is negative 4 plus second square root of 784. Use the arrow keys to bounce around. I'm going kind of quick because hopefully at this point you know what you're doing. All over 4. I click enter. I got nice, beautiful, clean, regular 6. So I got x equals 6 for one of them. Oh, trying to move me. And the other one is the same thing, but with the minus version. So let's save some time. I'm going to click the up arrow twice to highlight and click enter to copy and paste them down here. I'm going to go right over that plus sign. And I'm going to click the minus button to swap it out and click enter. And I got negative 8 that side. Negative 8. Okay. Reread the question. It says determine Kelly's age algebraically. Well, Kelly's age is X. Sweet. Good for us. I got 2 answers though. One of these makes sense and one of them makes no sense at all. If X is Kelly's age, what makes sense? 6 or negative 8? 6 does. So we're going to throw out negative 8. Mr. K, why did we get 2 answers? Because it's a quadratic equation. It doesn't know what the context of the problem is. If it said determine the temperatures of upstate New York, negative 8 could work, right? Because that's the temperature. If we're talking about someone's age, oh, there's the bell. If we're talking about someone's age, 6 is the answer, okay? So we're going to type that really quickly. Determine Kelly's age algebraically. Let's write a quick sentence. Kelly's.
Guidance office. Brianna Relier and McKenna Pratt. Brianna Relier and McKenna Pratt. 2 guidance, please.
There's the real answer. Kelly's age is 6. Great. 6 years old. I don't know. I'm being lazy. Kelly's age is 6. So Kelly's age is 6. Probably 6 years, I'm assuming, but it's 6. Now, down here, there's one last part. State the difference between Julia's and Kelly's ages in years. So you have to know how old they are. Well, we know Kelly is 6 because we just found that out. So really quickly, I'm going to take a note. Kelly is 6. And then Julia, we don't know her age yet, but her age is 2x plus 4. Okay. So Julia is 2x plus 4. We know what x is. We found it, right? Look, x is 6. So we're going to swap out x for what we know it is, which is 6 plus 4. And then really quickly, 2 times 6 plus 4, well, 2 times 6 is 12, and 12 plus 4 on a good day is 16. So Julia is 16, Kelly is 6, and they said, what's the difference between their ages? Well, that's easy. How far apart is 16 and 6? They're 10 years apart. So we're going to write really quickly the difference in their ages. I'm going to type into myself here, huh? The difference in their ages is 10 years. Okay, and let me get rid of the italics because it drives me bananas. That is the real answer to this part down here. So make sure that that is the thing that you put the box around. The difference in their ages is 10 years. Big question. Lots of points available here. It's at least a 4-point question, so hope you were able to stick with it.